Hello, test. Do you hear me? Is it good? Louder? Super well? All right. Cool. Hello and welcome to Dispatch Volume 2. And welcome to pixel.forest for those who haven't been here. We opened in September and we're a space for new media art, co-working space. We're hosting workshops. I will talk a bit about that later on. We have quite a few workshops coming up in the next months. And yeah, so Dispatch is a recurring event series that we started 2 months ago, and which is basically hosting people like artists from everywhere. And yeah, we're hosting like performances, presentations, mainly about like touch designer and V4, but generally about like new media art. And yeah, we got 4 speakers today, or presenters. Tiziano Mirabella, who's gonna be starting now, Joel, Schaefer, Dylan, Cruz, and Ployz. And yeah, I think they can introduce themselves in a minute. And yeah, we're gonna be streaming this, so this is also recorded, so you can rewatch it later on. And just a few organizational things is we've got like a code of conduct that code of conduct that you can read on the on there on the wall. If you want to go to the toilets, that's like outside the main door and then to the right. And smoking only like downstairs, please. I think that's kind of all we've got to say. Yeah, we actually got an installation in this room from Anna. So if you want to check that out, you can go to that room. And yeah, without further ado, I think we can get started with you, Tiziano. So you got to be pretty close to the mic if you. Huh?
With the mic. Hello. This works. Hello. So I'm Tiziano Mirabella, and I'm a credit technologist working across visuals, interactive installation, and light design. And man, I use for all my work touch designer, and I love touch design. I start back in the day. I have a background in architecture. I start back in the day, make some motion graphic, projection mapping with Cinema 4D, and then and then some I experimented with lights, working for clubs, and always I want to have a platform when I can program basically and interact visuals and lights together, and that's I came across Touch Designer and I fell in love, and I start to use for my project because it's so a platform that you can program basically everything together. Today we're talking about lights, and now I program and make all my program lights with touch, and the way actually that I'm doing that. So here, for example, is one of my first like back on the days project where I use like visuals sending to light. So one things together in one textures, sending like mapping in a 3D space the visuals to the lights. And another example of my work is in a club in Berlin called Else. These are the 3D rendering for the design that I made, and this is one of my first kinetic installation. Um, Basically, it's an open air floor where we want to difficult because 10 o'clock closes, so operates during the day. So we want to have a light installation. What to do because you need to, yeah, you won't see much. So the idea was to create kind of with industrial looking some kinetic lights. So we build these tubes, metal tubes that they can move at the beginning. We want to do with winches, so to have winches, but the problem was with winches is about safety because you cannot have winches above people. Cables can go down, can be dangerous. So in the end, we decide to and also you need to have 2 winches per pipe, so it would also be way more expensive. And So in the end, we find the idea to have these rotators. These are Wahlberg rotators. Is a company in Denmark that makes this endless rotator. Means they can rotate 360 degrees. And we basically build this on the roof, and we build these pipes with metal pipes with inside some COP LED. And Julius is my colleague. We work together, and basically does all the electronics, build all the LEDs together, and I make the design. I make the touch designer. And so this floor, it's basically all. Yeah, this is a bit like the first time that I was programming, and how bit the floor looks like. And yeah, we also have some LEDs across the floor. And on the back of the DJs, and that's on the left side, we custom made some industrial lamps. And yeah, that's a bit it. And so we have these kinetic lights rotating, and everything basically is built touch designer. And this is my old program, sort of to say. Today I will show you actually my new approach with pop operators, because this basically was the old way as I was programming touch with chops. And this is a standalone program, means like there is no real operators. It works out of just start the program and it will works automatically. Yes, some audio detections in. You have to actually detect that, so the BPM with AI. And then there's some audio for kick, snare, and common stuff for techno, and just go. And automatically you can use the fader just to reduce the lights. And you can see the mapping, basically what I used to do. Basically you have this 3D floor where you can basically map with textures, basically the lights. And and this basically was my common old way to build and program with touch. And basically now the new pop operators are out. And so I decided to basically rebuild completely new the system and see what's possible with pop. And now actually DMX is endlessly different with pops. And well, it's amazing because finally you can treat, you now you have attributes, so your DMX channels are attributes, and you can write pixel shader with that. And it's another way to program. You don't need to pass from geometry. That's also very efficient because you run on the GPU, and you don't need to anymore to use all the chop and make the shuffling for the channels. That was very actually convoluted and complicated in a way. So today I'll show you Lumina. In the beginning of the year, I start to build a completely new system with pop, and I start to explore what was possible. And I ended up actually building a kind of kinetic system where you can animate kinetic lights, and you have a tracking system that auto-solving the pan. Because like the thing is, when you want to have like tracking system with moving heads, you want to point at something, and the problem with moving heads feature, you have a constraint of the feature itself with pan and tilt. So I try to solve this problem and see how I can do this with a pixel shader. And I will use a program to visualize this. I don't visualize this with Touch Designer, because when you want to visualize light, it's best to have an external program that just do that. It's called Capture. All the light design are using as a pre-visualization program. That basically then you can send some DMX and you can pre-visualize the light and how almost work in real life. And so my new program Lumina, what I tried to implement first of all was an auto patch fixtures, because when you have like DMX and fixtures, you always need to take account the channels with kind of fixture use with moving heads and stuff. So instead of to do manually, I implement this with an extension that you can just either use a table or use a specific file for that, and you will automatize all the process, make your channels, create like a ready head that you can use and send DMX directly to Touch Designer. The second thing is you use a 360 texture mapping, meaning that I have like boundaries where I can put all my feature with my heads, and all we're gonna be mapped in 360, so I can have things coming from the left, right, on top. And then I implement this kinetic system where I can animate kinetic lights and a tracking system for moving heads to point at things in space, and to basically auto create a position for that. And else on top of this, since you can write pixel shader and you can manipulate attributes as you want, basically I create an interaction with that, meaning, for example, I can decide what hit points, so I can pass data for hit points. So if I know that I hit a panel, also the panel can go on or receive color, the same colors. And now I will try to make a small presentation of it. Maybe I put the audio a little bit higher. See if this works. And this will work basically in real time. Stop. The floor is a very basic setup, just mostly for me to understand how to work with the program. I have some 60 moving heads around the floor, some video panel on top, quick kinetic, and sides of some video panel on the sides. See? Sorry, there is something not working. I see directly. I think I need to do something in my patch, because I was messing around today. All right, now it should work. Yep. Yeah. Nope. Amazing. Okay. I tested this before. Why is not working? Okay. Now hopefully it works. So yeah, that worked. So here we'll just now stop. All right. So you can see basically capture. This is the 3D visualizing program on the right, and basically I pass directly the MX on it. So now, for example, I can change content, and so I can visualize directly what the lights are doing. Maybe I can also put a little bit of more. Let's just visualize better the floor, some ground lighting in it. So you can see a better look of the floor itself. And that's basically the touch designer part. So you can see basically the moving heads that are already tracking the kinetic system, and they basically go directly and point aim off. So that's a pixel shader that I developed to do that. And so basically, if you my patch, you see my patch, I have my content play, and I have my DMX solve, where I have my moving ads, and I actually can also, for example, make something that is more bright, where all the moving ads are on. Maybe we can do this, and then I can control for my content. Maybe just make moving ads as a point. So I have different movements. This is a normal movement for moving ads. Then I can have like just maybe like make just as a point. And this is a goal solver of the moving ads, meaning they will point directly in a goal, and they will follow the goal. So I can basically, maybe we can close. My seagull, so I can basically move the seagull. So let's close live. So I can have like kind of a point goal, and this was the first thing that I implemented. So they gonna follow the point that I want in 3D space. And now I make my 0 point. And this was the first thing that I implemented. So basically I can have a point, I can have all the moving heads, left and right point, what I aim for. And then basically I implemented the second thing, just normal movements for the moving heads, for multiple moving heads, and then the kinetic tracking. So at this point, I have a kinetic system. You can see in my geometry with some panels and some points, and basically I can choose which point they're gonna aim. I need to get this out. And I just can figure out with my point indices, for example, so I can say, okay, all the point of the moving heads point on 0, 9, and they're gonna directly doing, for example, like if I want that all the moving heads point in the middle of my panel, so 50, I can just tell them already create this grouping, so they all go 1 point or different grouping point, and also the panel get activated when they got hit by the moving heads. And yeah, that was all done basically creating my custom pixel shaders, where I get in the geometry of the moving heads and then create some maths to point at. And then the very difficult thing is basically resolve the movement, because you have like panel rotation that are limited, like pan, or it's limited like the mechanical limitation from the rotation and from the tilt. So for the vertical movement, for the horizontal movement. And you always need to also take in account where the real fixture is. So it's left, right, and where point at. And well, I wrote a little bit of code to solve that. And it basically does this. I have some different target mapping custom, and then I basically resolve this, and I need to actually solve this for different planes. So if the moving heads are left, I need to re-rotate that right, or in which position the moving heads. The cool thing that this is working, basically just having in the end, I can just position in the real world where are my moving heads, or where are my features, and then I know where are like my target points are, and this will resolve automatically, basically, the the target, so they will point directly at it. And like this, basically, then um, you can basically move just the panels, and the moving heads will follow. And I will show you like from the content. Let's, for example, be in 11 here. And actually, this is also pretty efficient because actually you animate everything with sample textures. So if I now, this is 0, meaning basically the movement is null, and I go 1, it means the movement is full. And basically I map this texture not only so to the color, but I'm mapping also this texture basically to the position. So instead of just like now a constant, basically I can just send then a ramp, and then basically this will move mapping on the ramp itself. And I mean, I can make horizontal, then they will go horizontal, vertical, this go on vertical, and so on. So basically, then you can just animate it everything with simple ramps. And these also go all across the screens and the moving ends itself. Because, for example, if I have, can I just take this out? For example, if I make horizontal and I just cut this, I mean now the moving gets, the things go crazy. Maybe just we leave like in full. But you can see, and I want to send this, for example, to the panel. You can see that basically the texture is going not only to the video wall, but is also going to the moving heads, because it's all mapped in the same way. So like here you can see a little bit how everything is mapped in 3D. Basically I have the texture going between all the video panel and going to the moving heads. Yeah, and that's basically is my way to create visuals and light and animate everything on the same basically way, and from the same source, so to say. And then of course you can have different mapping. You can also have mapping on the top, mapping on the side, or basically yeah. And yeah, basically that's it. That's my new way. So I don't know, it gets very technically because there's many parts to look at it, but basically yeah, I have my features, then I group my features, then I have some debug things because I can activate in case the moving heads to see which ID have my moving heads. Now you see it gets red, so I can go across to just see which moving heads is activated. And then I have basically the real like fun. He has this pixel shader where I map basically the visuals and the textures to the moving heads or whatever. Actually, it's not only moving heads. I can put any type of light. I can put any visuals. I just need to decide where are the boundaries. Basically, you can see here. These are basically my real boundaries. So the cube mapping that happens, and just need to where also depends from the position when I'm gonna build my feature. It's gonna be mapped differently. Yeah. Sorry, I'm maybe not the best to explain that, but that's it. If you have any questions, yeah, feel free.
Yeah, does anyone of you have any questions for Tiziano? Yeah.
So there is not really audio reaction here. That's the thing. When we do stage design or we do visuals for design, actually we don't really have audio reaction. What we're using is like drive scenes. So we create some scenes and then we draw. We use audio, of course, and I use live, basically. And what I'm doing, I create some preset, and this is actually the usual way that you create lights. You don't have, of course, you always follow the BPM, but you follow some part of the, you create some basically point and features, and from that you animate basically your light. So for example, you have the truck, and I use this live 2DD to get the data in Touch Designer, and before I was doing actually with MIDI. So I would put, for example, where it was the kick, I was putting the MIDI note, and this will trigger the scene on the kick or a light on the kick. Now I use the OSC way because, of course, you have more range than the MX. So here, basically, you can see that's why it was not working before, because I didn't activate the live functions. So I basically write my automations. So every automation drive like preset one, and here I can change, maybe I can also do this live. If I change the preset, you see, they already go to the preset one. So here I can go across all my presets. And here, for example, I don't know, here I have preset one, this happening, going down, preset two going up, and then maybe you have like, if for example here, I have like red going on. So I really write when red, here you can see on the track there is red going on. So I write all my automation actually, yeah, on the track, and I use live for this, and this pretty nice workflow because in the end you have one track and you can write all the automation here. And yeah, I also have another workflow. Once this is finished, actually record in Touch Designer, do this automation, because then I can basically render everything with that without have live playing. But this is actually a nice way because then you can play live, you play music, and you play basically the presets.
I actually have a small question. Are you like performing this live? Are you going there regularly then to perform, or are you like giving them a system to work with? Like in the club, like are you delivering them like this and they can play with it, or are you performing actually?
For clubs, I basically create a standalone system. I usually go with the audio, and then I use audio reaction there. Um, for festival, I operate that. So I create a system, and then I can basically operate them, something like that. Yeah. But this is the way when you make basically a live show. This is the way that you pre-visualize everything, you pre-prepare everything, you have already everything working, and then actually you have get the time code. This is time code of the tracks going, and because with the time code, then you have different time code with different tracks. So at the end, when you see this big show, what's happening? Someone plays play. You have time code, and you don't touch anything. You don't want to touch anything because it's everything pre-programmed and pre-established. Let's so hopefully not running any problems.
All right, thank you. Thanks so much. So if you have any more questions for him, you can just ask him directly. We're going to take a quick break and then continue with the next presentation of Joe. All right. And by the way, you can buy drinks in the kitchen either by cash or PayPal. Just take them, and there's a QR code that you can scan. Thank you. All right. Okay.
Okay, test. Hello. Yeah. Hi everyone. I'm Joel, and I'd like to present a project I was working on. A presentation called TDML Touch Designer Machine Learning Toolkit. Short words to me. I'm a media artist, creative technologist, currently living in Potsdam and also studying there. I mostly do audiovisual stuff, mostly performance, bit installations as well. I was doing also more like non-real-time 3D. So this is with my new media art collective Latenta Raum together, and this performance here with my friend Anna Ferro, Tanzania. Yeah, so I initially have background more in sound design and modular synths and music and DJing, but yeah, over the years came to visuals and creative coding and fell in love. So yeah, also over the last 2 years or so, I go more and more into building little tools or instruments. Yeah, so mostly touch designer, little bit Max for Live, little bit C++ experiments. Yeah. That being said, back to subject. So TDML, what is it? Yeah, it's a toolkit for touch designer, as I said already, aimed at high-level, quick, iterative workflows and training small models and inferring small models. Maybe a little bit to the background. It's mostly started like as a learning project for me to get better at Python and Touch Designer and learn about script ops and extensions and yeah, get more into that. But I was also really I really like to use Flucoma, Fluid Corpus Manipulation Toolkit for MaxMSP and Super Collider. It does a lot more than machine learning, but there's also like a little neural networks, and it was really fun playing around with them and yeah, kind of then using it for Touch Designer via OOC workflows. And I thought, okay, for these iterative things, would be cool to have it directly in there. So yeah, that's like the motivation background. So what it's useful for: classification, regression, latent exploration, clustering, data visualization, or dimension reduction. So to quickly show what's included, and also, have to say it's like really early state. Today I'm gonna show like these 4 components a bit, like 2 neural networks, very simple ones, feed-forward neural networks, classifier and a regressor. Then we look into the UMAP component and the data setter. The other ones are really, I don't know, pre-alpha state or how you want to call it. So there are 3 more, like LSTM networks and a variational autoencoder experiment. But this is already everything really work in progress. So we'll today focus on this. I think I'm gonna sit down. As to notice, so it's mostly based on these 3 Python libraries, or wrapping around them, scikit-learn, UMAP-learn, and PyTorch. So these from scikit and UMAP for UMAP-learn. Yes, so back to the presentation. Maybe a little overview for the presentation. I thought showing more little examples that illustrate the workflows or illustrate like what you can do with it. And like a few where really like go into the network and show the workflow, and maybe a little live demo of training. Okay, but to start very simple with like the most simple example, probably classifying 2D mouse position into 2 screen regions, up and down. So obviously this is like really easy to solve problem. It's like one logic operator. But I thought it's like nice to illustrate the difference in how we solve classical problems via building the formula kind of ourselves with jobs and yeah, figuring it out, building it via via the machine learning workflow. We like accept that we don't know the formula, and rather than trying to figure it out, we are giving examples to the algorithm to like come up with our own formula that solves the task. So to show this here in this very simple example, giving a few examples for region A and a few examples for region B here. So, and then we can train it. And see, yeah, it's doing the job. Not as accurate as it might should be, but yeah. So, and here, if we look at the network, it's like really different. This is the here you see the data setter. So this, the role of this component is really just to create a table where you pair input and output data. In this case, 2D positions with labels. Yeah, and then a classifier at the end. So moving on to a bit more. Okay, no, wait. Here's another example for 2D classification that's like a little harder and a little more meaningful than the one before. So yeah, you see the training points I put in here and how this works. But let's move on to something more interesting. So classifying hand tracking. So I have a leap motion here and this little visualizer at my left hand, you see. And put it here. And this is classifying between thumbs down, thumbs up, and peace. And I thought for this one, we might look on how to quickly do this live. Okay, so now this gets a bit complicated. So now let's clear this data sample, this data set here, and yeah, start off with peace. So I like put my hand in a position which is peace, and then yeah, go to the data setter, check that it's empty. Check that it's empty, and yeah, click here on add data sample to give it examples of peace. And here I also like move around, so I can like include in the data set that peace is not about the position really, but about the position, the relation of the finger joints to each other. So then moving on to thumbs up. So here is the same procedure, showing trying to get tracked. I just do it, and so doing thumbs up, adding data samples. Thumbs down. Probably should be enough already. And let's here then on the classifier, there are 2 pages. One exposes the hyperparameters for the training, so you can set the size of the neural network or the amount of layers here. Yeah, and the other parameters. So with hitting Alt and hovering hovering over the parameters, there's also the help text from the scikit documentation attached to it. So yeah, it's kind of then explaining what it's doing. So, but now let's just hit train and see if it's working. Seems good. And maybe interesting here is also to show this iterative workflow, that if we see, okay, so this is piece, this should be piece, but I put it here and I see it sums down. So, well, that is not represented in the data set yet. So then it's like really simple to just go back. Put piece again and yeah, go to the position where it was failing, and yeah, give it some more samples of what it actually should be. Then retrain and check. It already now is also up here where it was the first thumbs down. If it was failing, it's yeah, doing it right now. So this, yeah, like illustrating a bit the workflow. Then I prepared, yeah. So, okay, like, then let's look into UMap, and this is then also useful to maybe explain why did it just work before. So if we look in this network, it just takes the table which I just created before in the other slide. So it's, you see, it's just a table from before. And it goes into these UMap components. And what UMap does is reducing the dimension. So the feature vector size in the beginning was 64 channels. So like the bones, and of course we know, yeah, okay, this can be visualized as a hand. It is actually a hand. So, but visualizing the latent space of it, yeah, helps, and to see what's actually going on in the data. Of course, we know, yeah, thumbs up is different than piece, so it should be included in the data. But yeah, the UMap lets us reduce the dimensions, the 40 or what it was, down to 2 or 3 or any lower number. And let's just do it here. Takes a second. And it shows an approximation of the data samples and how they like relate to each other. And here are a few components that change how it looks and how it's computed. So the lower the neighbors are, the more we see the local relationship, and the higher we go with the neighbors, the more it gets like the global pattern. And here we, for example, with this, we see really well, like they are nicely separated. So that means, yeah, that classification probably would work on this. So this UMap visualizer maybe showing also shortly, this is just has the UMap component in here. So that's maybe also a bit like how this toolkit is thought, like a mid-level thing that yeah, the base components just do the computation and give out tables here, and then yeah, to build like a visualizer around it, then would be like this, or like a tool out of it, really. Okay, maybe we can also, because it's fun, look at it in 3D shortly. This also works. Okay, then moving on, audio. I have to enable the cooking. And here you see already my voice is one of the audio inputs. The other one, I have a little tongue drum here. Getting some meditation vibes. And yeah, like for this example, I use this TDM-FCC by Patrick Lechner. It's like a nice tool to extract the mel frequency, Chebyshev coefficient from the audio, which is yeah, can be imagined more like it's like a frequency band that you see these filter banks here that works like how to say that it is logarithmically ordered here, so it gives a better the frequency band we get out of this is like a better representation of we actually hear sound. And we look in the network, so this is like needed to because with raw audio or just like a huge FFT table, it's a bit harder to do stuff. So we want to extract meaningful features. These are these MFCC bands, and but after that, the workflow is exactly the same as I showed before. So I recorded some of my voice before and some of the tongue drum. And yeah, with audio, I find it especially interesting to look at the UMAP structure of it because, yeah, looks kind of cool to see the audio files in 3D or 2D, or like what patterns they create with this UMAP. But also, again, here we see like why it's working and maybe why it's sometimes not working. Yes, so to move on and finish up classification. Let's look at regression. So regression, so with classification before, it was always like we give data in and we give it labels, and then yeah, it's either it is the label or it's not. I mean, we can also compute the probabilities, which then is kind of like also a continuous value we get out of it. But actually, it's like, is it this label or not? Or is it multiple labels at the same time also works or not? But it's not really continuous values. So with regression, it's works very similar, just that here we get really channel values out. And so if I change the input here, you see it's continuous values. That's like just what regression means in this context. And so I prepared this example where I placed here on each point a preset of this one visual synthesizer. And so to show it here, so here, instead of having a label in the second input of the data set, I'm pairing the 2D input with parameter values from the visual synthesizer, so presets basically. Yeah. And so then this gets like a preset interpolation between yeah, a lot of presets in 2D space right now. Just as displaying the regressor. But again, here also instead of 2D, we could also again take the leap motion input, and I did exactly the same. Just instead of 2D positions, I can't remember the hand positions, but I put some gestures here, which I paired then again also with a visual synthesizer preset. And then by moving my hand, I'm again interpolating this space, this parameter space. Yeah, and this also may be interesting for exploration because, yeah, like how would you imagine like what's between five, like the middle or something between 5 presets is kind of hard to imagine or so. Between 2 it's okay, but yeah, so and this can then be also interesting to just like explore the parameter space of your output, really. I don't know, how are we with time? Should I? Okay, then I'll move on to with 5 minutes. Then I quickly show with this example how we might add another preset here. So sorry, it's like old references. So yeah, deciding for a new hand position, maybe we take this. Then deciding for the preset. So I'm just gonna do something quick here. this, and we want to associate this or pair this with this hand position, and then so here I have a parameter chop which just gets that and it just deletes out the resolution because this I don't want to change, and add another data sample for this. Then retrain and hit the export binding here again, and we see roughly there it gets to that preset and it changed the behavior a bit. Yes, so as a final slide and example, I have then a combination of audio and visuals. It's also a regressor here, but this one is and for the visuals I have here from T3D by Joseph Peltz, the Julia fractal, and the parameters here are like these, how to define the fractal, and the fill color. And on the other side, on the audio side, I have here a granular synthesizer. This is by me, and yeah, like here really simple, it's just one voice. Here just 3 parameters, so the start time, the spawn rate, and the length. And I have to enable the audio here. Sorry, that was loud. And this input again, deep motion hand tracking. And now I'm driving, but now I'm driving both with it. So yeah, I'll just do it. If I turn out the filter here and decrease the reverb a bit or turn it off, it gets a bit more visible how okay, yeah. Where am I? Yes, so this, thanks. Yeah, so this as a example to wrap up. Also, I found interesting like how you then combine different types of input, output data, and yeah, maybe like see how you can build relationships based on your input and that, and pair it in interesting, funny ways or so. And yeah, thanks.
Amazing, thank you. I really love the I love the 2D parameter thing where you like interpolate from one preset to the other. It's super inspiring for like PJ softwares or something. It's really cool. Yeah, does anybody have questions for Joel? Yeah. Maybe you just
when you are touching make the sound, the noise, making the noise from this instrument, and then it generates 3D data in 3D space. How does it work?
You mean the drum and the audio example? Yeah. So this works. This right? Yeah. This works in a way that's like, well, you asked for the audio, so this is actually 14 parameters here that we get in, and it works. So it's the UMAP algorithm. So what it does is it compares the relative distance of the data points, which are first in 14-dimensional space. So, but you can still compare distances, relative ones, and then it like compares the likelihood for a given number of neighbor points to be how likely they are to be at each other later on. So, and then it embeds that in lower dimensional space while it's trying to preserve these likelihoods. So trying to preserve the original structure in the data. So for example, when I hit this tone, the 14 parameters are describing the frequency, right? So and this one is closer to, you know, another high tone than to a super low tone. Yeah, and this relationship which is like when we hear it is like super, you know, intuitive. So it's higher and it's closer to something else that is high, and something lower is closer in the data to something else that is low. And yeah, this algorithm UMAP is like just how I try to describe doing that.
okay, thank you. Maybe one more question. Anybody has another question?
Algorithm is by you as an external. It's an external algorithm you use on an external component. Maybe you can, I don't know, can give a bit more detail how it works, like mathematically, how the dimensions are reduced. So are these values like add up for the lower dimensions, or how does it like work?
So first, no, it's not by me, and I also haven't written this math behind it. So I just used the UMAP learn library, which is a Python package. Yeah, and like how it works, there was what I described. So you have a high dimensional vector, and you can still do vector math on this and compare distances. Just a problem if you do absolute distances in high dimensional space, it gets meaningless, and it's all like around 1. So absolute distance doesn't bring anything. And I think, but the general idea is to reduce it while preserving the original structure in the data set. So and that's all kind of distance based. But like this problem of dimensionality I said with the absolute distances, it's solved by this algorithm through this looking at just a few points for every point, and then like getting a relative distance from one point to each other, and then they like calculate the likelihood that some points, high dimensional points, are close to each other also in low dimensional space. Yeah. Sorry, it's my best take on it.
Okay, I also think, I mean, it's a huge topic, and we've got to move on. So maybe you can just ask him directly. So the question is if it's locally running and if how fast the processing is.
Yeah, it's all locally, and also the examples we saw, it's all only CPU. It's just like very small data set and very small network, and also simple neural networks. Like if you use the LSTM ones, they are recurrent, so they take much longer. And also it takes much longer the bigger your data set is. So like it was so fast because there was just like 5 entries or 6 entries in it. Um, yeah, like for these simple things, I think it's cool and efficient. Also, it runs at around. So this one's not running right now. So it's mostly below 1 millisecond latency. Um, 0.2 to 1, I'd say, depending on the size of the neural network, the size of your input vector. Like if you get a huge stream of data in, then it will also be slower. Yeah.
We gotta move on. But thank you so much. And yeah. All right, so we maybe take like a 10-minute break, and then we got Dylan coming up next. Okay, so let's continue with our next presenter, Dylan Cruz, also known as Memocrime. All right, the stage is yours.
Sweet. Hello, everyone. Um, this is my presentation. It's called Tooling Chaos. Is everything good? Can you guys hear me? All good? Um, So the kind of main concept with this is it's like a touch designer kind of shit post. Like I have a bunch of random projects that I've just kind of like compiled together, and they kind of encompass this, you know, the overall theory of chaos and how it can be used in like a data science context or whatever. So first off, this is me. Hello, I'm Dylan. I make stuff in Touch Designer. I'm trying to become like an immersive interactive developer, but it's fucking hard out here. But it's very fun, and I've got a bunch of different fun experiments lined up. This is a picture of me in a pub. Chaos as a concept. Chaos, yeah, it's like there's a lot of shit going on. In general, I kind of like to sort of take upon stuff from, you know, what's going on currently with like the age of information abundance and just a fuck ton of shit happening on like Instagram and stuff. You scroll through and there's just so much. Your brain is being like just front end, just like rammed with information and stuff. And I kind of like that. And I use it a lot in like my practice because it's very easy, if you guys have used Touch Designer, to kind of just crank up the values and just go crazy. Yeah. And I said here that it's safe to say that chaos and all of its glory won't be leaving us soon, and it's probably going to get much worse. So why not embrace it? Take it in instead. Look at the storm, and step into the storm. Why don't we? Okay. Yeah, if you sort of take a minute to think about what makes something chaotic, it's a little bit strange. So this is kind of like I was thinking about this by myself because I kind of wanted to implement more like intensity in my projects, like some crazy shit, you know. But as I said, as are with most feelings, describing it is kind of useless. So you sort of just have to describe what elements that make it up. So I've got like, you know, quick succession of audio or visual elements, lots of kind of weird shit that you don't understand happening, unpredictable patterns, tension, overstimulation of senses. So there's like sound, visuals going crazy, smell, tactility. Oh, yeah, I don't know if that's a word, but it sounds cool. I think that's a word. I'm being self-conscious in my own presentation. Okay. I'll go over to my project. So this is the little thing that I did here for the presentation. Where do I start? So this is kind of like the face tracking stuff. I don't know if it's working. But let me move this over. I should have probably tested this before. It is there, but it's not working. 1 second. Oh, I know why. I need to do this and then boom. So this is a little face detection thingy that I have. As you can see, this is all of you amazing people, and these are all of your faces. And if I go out here, you can kind of see that now all of your faces are being shot through. It's kind of like the lighting's a little bit bad, but this is one of the first things I wanted to show off. So it's kind of like a little facial detection software. If you move around, you can see all your faces change and stuff. And I kind of like this as another concept leading to the sort of information abundance mindset of things. And I have a kind of like a few little things to show when it comes to this. So this basically, this whole like kind of camera with the face tracking thing, it will be throughout the entire presentation. And I can kind of just layer it on top of stuff. And first, I'd like to talk about these little things here, Boids. So I made these a while ago. It's like a fun little particle system with randomness and, you know, unpredictability. And it creates these kind of nice little fishes that move around. You could do some crazy shit. So one of the main concepts of like chaos and stuff is that you can really, you know, you can do like making the speed crazy or doing whatever, or like attracting a lot or doing some annoying stuff. But in order to kind of harness it in a way that's artistically nice is not very easy, because you know, you can make it look really shit really easily. I'll just kind of show again. So those are the kind of fishes that are going around. I can change like the sizes of the fishes too, which is pretty fun. If I go in here, I can make the fishes really big. So now everyone is being surrounded by these big fishes. Let me go back to here. So yeah, this is kind of like, this is another thing that I made. It's like sort of, you can like select out the presentations and they come here. These are a few effects that I made with the kind of, you know, toolkits that I have with you know, having this kind of information overload type stuff. We'll go into the toolkits now actually. So I've got like my main audio visual toolkit. This is one of the first ways that I implemented kind of chaos in my stuff. I don't know if it will work. Yeah, there we go. This is a very nice track. And as you can see here, I have some like custom data that I made. And it can be like, it's very simple data, but you have different parts of the data. So you have like the kicks and snares and stuff, but I made like a specific one right here. Fast low, fast mid, and fast high, and random numbers. And the way that this works is it kind of like, every time the kick is triggered, it does a Python script and creates random numbers. And those random numbers can then be used to sort of like really quickly change between stuff. So I'll kind of keep it going on in the background, and I'll go to some of the things where it changes a lot. We have this fun video flipper component that I made. I'm going to turn this on because this shit takes up way too much GPU, but now it's nice. And I think, yeah, so on the kick or something, it kind of triggers the, I think, yeah, I need to turn up the kick a little bit. But this is one of my sort of like first projects I made here in Berlin. I need to configure the thingies a bit, but every time it kicks, it basically switches through images. I also have another layer, which is this kind of cool thing that takes up a bunch of my GPU space, where it kind of pixel moshes, fades between stuff. I think this is really nice because, again, with the theory of chaos and the kind of stuff, like you kind of need to tone it down a bit. Otherwise, it can look a bit too crazy and get out of hand really quick. Yeah, I kind of like this. I also added some extra stuff. There's this nice little texture 3D. So it kind of loads it all up in one thingy as it's going around. Yeah, now I'm going to turn it off because it's making my frame rate really fucking low. Yeah. What else do we have? Let me go back into my main one. This is not my main one. Okay. So yeah, this is kind of the simple concept. Okay, it's not working, but I'll just go to it here. So I'm going to turn this off because it's pissing me off. Yeah. So this is the kind of like simple way that most people use it. I'm going to put this on because it's kind of like a bit of a boring project. So we'll have this playing in the background. There you go. Just so you know. Yeah, so the kind of normal way that people would make this is they'd use a sphere and a noise, and it creates this kind of noisy effect. You know, it's kind of like this. Also, you guys are all overlaid behind it. So that's kind of funny. And, you know, you could do some sort of like kind of basic, boring stuff like this, but it's not very fun. And you can expand upon it a lot with the use of sort of toolkits. Wow, I'm very deep in the Subway Surfers. If I go back here, not here, here. I have a few tools that kind of encapsulate. This is one of my favorite tools I've made recently. It's called Inverse Burn Filter. And it essentially adds like this really nice burn-in effect, which I used to make on Photoshop a lot. I'll sort of put it here, and I'll tweak a few of the parameters. This is made through just some very simple like lookup textures, and it kind of creates this really nice atmospheric blur. And you can change a lot of the stuff, like you can change the switch to switch between the colors. Now you have these nice blue fishes. You can also change a little bit of the ramp, not lock it. There you go. change the face, and then now you can see it's a little bit more, maybe a bit more. There we go. So now it's kind of got that cool phase thingy going on. Yeah. I'm just gonna switch back here. Yeah, so there's a few things about like tooling. You know, these are the different tools that you can kind of create in place to sort of, you know, harness this chaos and this crazy energy, and you can dial that in. Chaos challenges, balance. Make sure your stuff ain't too much. Chaos without direction is just fancy noise. That was what I was talking about before with the kind of sphere thingy. Like, you can make it really kind of boring and just have sort of fancy noise, but you can really dial it in, and have a lot of fun with it. There's also something to do with like the theory of like tension and release. I think that it's kind of easy with data and data science to kind of just have a bunch of, you know, wild stuff happening at once, but it's kind of important to reel that in and, you know, maybe tone down the strobe a little bit and then bring it back in when it's like getting a bit crazy. Adding space. With so much stuff going on, it's easy to get lost, so like leaving space for the particles to move around. You know, I wouldn't usually have them this kind of crazy close. This is another one. It's a nice little strobe that I made. You have a little kick here. So now it's reacting to the music that I turned off, but it kicks, and every time it kind of strobes. You can change the smoothing, RGB delay, a bunch of luminance and stuff. But again, like, you can kind of see how this shit gets very messed up very quickly. Like, there's a lot of stuff going on, and it's a bit too much, you know, too much stuff going on, which is why you kind of have to reel it in. How are we doing on time, by the way, quickly? Oh, shit, okay. Well, I'll go a little bit more in depth into how I did a few of these. This one here as well, I'm going to quickly demonstrate the audio file in. Yes, this audio part here. Don't know why intensity maybe is a bit high. There we go. So now we have the kick and the snare and the rhythm coming in. And now here I have the sort of, these are the main ones that I use when I'm like using the switch. So we can use the switch here in a really fun way where I've essentially remapped all of these different values to be very, very quickly flipping between the two. So if I put this here, you can see that it flips between the original image and the blob track image kind of quickly. I think in Touch Designer, this is such a nice way that you can create that kind of tension and you can flip between different things. It can be really fun. Yeah. This is a little ASCII renderer from Supermarket Salad, who's an amazing developer. And yeah, here's the strobe. You can kind of see the strobe a bit more in effect now that I've changed the values a bit. Just do a bunch of cool stuff with it. Dial it back, slow it down. Alright, turn the audio off again. And there's also a little thingy I made here as well for image instancing. This is a bit more like, I don't know, in-depth kind of Touch Designer stuff. I think I need to actually redo this stuff real quick. So let me just... Oh, I think this is a good time to talk about this. This is a texture 3D autofill for some of the Touch Designer nerds here. It basically just takes a folder full of images, and it will instantly fill whatever you want into the texture 3D. So as you can see right here, I have a bunch of cameras that I pulled off the internet. I think I did like a cool kind of, there's like an extension you can get on Chrome, which like basically takes an entire page's HTML, breaks it down, and takes all of the mass downloads every image. So I did this with a few websites, and I got like, you know, folders full of like thousands of images. I compressed it down because obviously loading every image in is bad for performance. You can see it's got a depth of 20, and there are 20 instances behind this. And it's also using the same audio reactivity from before. I'll turn that on a bit and you can kind of see. Just got some simple instancing here, with some lines, and they're sort of twirling and twisting with the noise. And this noise is obviously triggered with the parameters, the audio parameters to kind of make it pop and make it go crazy. There's also a nice little blob track here, and I know blob track's I didn't want to show too much blob track because blob track is a little bit overdone, but it does look pretty nice. And I have a nice little blob track here that goes between a lot of different stuff, and it's very laggy. Yeah, got a bunch of different blob track ones that you can render out here. Whoa, this is like going crazy here with the text. That's pretty fun. And again, here is the same kind of concept with the switch of the kind of chaotic, quick movement between the two inputs, which can be really fun. I'm just gonna turn the audio on again, and you can kind of see what it's doing here. It's kind of moving through and going through the different switches and doing some trail stuff. And there's just so much fun stuff that you can do with this, just making stuff as intense as possible and cracked out. Yeah. Turn off the audio again. There you go. I'll go back into the effects as well. I've kind of talked about most of what I want to talk about. Oh, okay. I'll go back to the face tracking. So this is some interesting tracking software. It's made by you guys probably know Torren Blankensmith. He's pretty good at all of this tracking stuff. And you can use multiple models. I really like this for audience tracking because it adds a kind of extra depth to the tracking. I kind of wanted to make it. I have a few, like there's like an unfinished component here. So that's Sarah being enlarged. My kind of process with this component was my friend was talking about some surveillance technology which artificially enlarged the faces of everyone. But currently it only works for one face, so it's kind of switching between Sarah and someone else. But it's quite nice. If I do it like by myself, you can see it a bit better, but you can move it around. It will attract different faces or whatever. But I kind of I want to make this this is my future goal, is to make this kind of actually encapsulate everyone and enlarge everyone's faces, like the kind of Massive Attack stuff. But you can also not just do face tracking, you can do object tracking. Hopefully this won't break my PC. There we go. So now there's object tracking. It's still getting people because you guys are people. And there's a nice little sort of mask that you can get out of it. You get a lot of data. You can also get UV data out of it. You can mask it out and overlay them on top of each other and stuff, which can be really fun. As far as the object tracking goes, there's a lot of kind of complex stuff here that I won't dive too deep into in terms of like centering the instances and making GLSL for each of the UVs so that you can kind of displace them and stuff. There's a lot of shit here to go through. But it's a really nice sort of quick and easy method. The only issue is that whenever I load up this presentation, it like crashes for like 10 seconds and then it loads because, yeah. I'll go a bit more into this video flipper as well. So this essentially like takes whatever folder you want. It's all modular, so you can plug in whatever you want. Takes whatever folder you want, full of JPEGs or full of whatever, makes them into a list, and then triggers this movie file into change based on anything. So you can add in kicks, you can add in snares. I can change this to the snare right now. So whenever the snare pops, take away the kick as well. Whenever the snare pops, the movie file would change as well. This is perfect when I'll go a bit more into how it kind of like meshes with this one, because it essentially like it does like a cache and it feeds it back onto itself with optical flow. And this is a sort of data motion component by this dude. I'm not going to try and pronounce that because that's a lot of words, but it's really nice if you kind of have quick moving cuts between either videos or photos, because a lot of people make like data motion components and kind of just have like one person moving, but having this is really kind of nice, and you can instantly switch between, and it meshes into each other. You can also fuck with the display somewhere here, yeah, and you can really fuck it up. So now there's like a bunch of noise to it, turning down the UV weight, so it's kind of meshing into each other. Again, you can make it very chaotic very quickly. Whoa, that's cool. What the fuck? It's like feedbacking into itself. Oh, I like that a lot. Yeah, dude. Sorry, I'm getting off track. Okay, anyway, Touch Designer. What else can I talk about here? I honestly don't have that much. How much time do we have left? I can go into like a. Should I finish now? Okay, I'll go back to the presentation and sort of go through it. I'll go back to the thingy here. Thank you guys for coming to my presentation very much. Yeah. Should we can do the Q&A now. I can go to another project. All right, fuck it. I'll go to another project. Let me find another project to dive into. Actually, no, hold on. Let me go back into this. So I'll talk a little bit about the kind of way that I. Oh, look, this is kind of nice. Everyone's all faded in with the fishes. This is everything combined together, just put straight out into the projector. I'll talk about this because I kind of like this. I made this specifically for this presentation. It was really fun to make. I was giggling by myself when making this. Again, I'm using my T3D autofill to basically get all of my presentation images, autofill it into a texture 3D top, and then just instance them. I use a really neat thing here from the render called a render pick, and a render pick essentially takes my data and puts it into a chop from the render. So if I click here, you can see that the render changes. If I move this here, so this will show me which instance I've picked. So if you're familiar with instances, you'll know that they're indexed like from 0 to, there's like 7 here, so 0 to 7 or 6, I don't know. And you can click here, and the instance will change here, which is really neat. And there's a little chop exec that I made here. You don't need to do a chop exec because there's a convenient little render pick callback here. But I'll go into this chop exec and kind of show you what this does. This is also probably not the best way to do this, but it's kind of how I did it, with the help of Billion, which was great. It goes into the sort of the instance value that you've taken. So if you click on the square at value number 5, it takes that value number 5 and it goes to wherever you want it. So I have a bunch of network paths lined up here. And it also changes the scale. I wanted to do some cooler stuff with this, like maybe it kind of interpolates and it goes boom, and it gets like this cool kind of scale effect. But I didn't end up getting around to it. And then it does some stuff with like, you know, length of network paths, and then it creates a floating pane network editor. This is another one of the really cool things about Touch Designer is you can kind of like access stuff that you shouldn't really be able to access. Like you can access any of these actual node positions and kind of move them around. So this is my first time messing with that, and it was very, very fun. And I have just like a simple. This is originally a component which like does differential line growth, but that shit was too complicated for me, so I just made a little circle with a noise. And then another thing about Pops, which is really nice, is this circle with a noise has been resampled, so it's got about 510 points. I don't know how clearly you can see that. And basically, to get these things to conform to the lines, I used a quick little line resample to resample into 6 divisions, and then a pop 2, and you can see those 6 indexes, which have all of the, you know, the stuff placed on top, which is quite fun. This was a really fun little project to do. There's also a switch here, which is supposed to do something. Oh yeah, it changes the level. Oh, sorry guys, fucking hell. So if I press 2, it like sort of switches between 2. What was it? Okay, I'll just manually do it. Changes between like the convert. But this is from like another project, so I don't really like it that much. Yeah. All right. I'll just go back to the thingy, and I'm gonna put my stuff here. So yeah, that's my Instagram if you're interested and stuff. This is the I'm gonna do a touch designer beginner workshop here in that room right there, on the 18th of April. If any of you guys are interested. Also, if you scan this QR code, it should take you hopefully to the event site of Pixel.forest, and you can go see everyone else's workshop. We've got quite a few workshops going on here in the future. It's gonna be really fun, and yeah, should move to the Q&A.
Does anyone have any questions for Dylan? Nope. All right. I mean, if you do, you can also ask him in like directly. And yeah, maybe you can actually open the Pixel Forest website. 'Cause there's also if you look at the screen in the entrance, there's a slideshow with all of our workshops coming up. But basically, yeah, the next 2 months we have a lot of workshops. Yeah, Dylan is hosting a beginner workshop. I'm also hosting a beginner workshop in a month. And yeah, actually tomorrow, but that one is already sold out. But on Sunday we have a really interesting wireless MIDI workshop, which is like nothing to do with touch or V4. It's just like mainly about physical hardware and sending like MIDI signals via I don't know if it's Wi-Fi, but some kind of wireless, some network thing. Huh? Radio. All right. And yeah, then Dylan is hosting one, I'm hosting one, and we got an interactive particle systems one with V4 coming up in May. And so yeah, just watch our website, and we're gonna be updating it. There's probably 2 or 3 more gonna be appearing there soon, and it's not on there yet, but thank you for that effect. There's gonna be another dispatch on May 29th, so you can already save the date. So this is gonna be around every 3 months now, like this kind of event. So definitely mark your calendars. And yeah, was there anything else? No. All right, cool. So we'll take another break, and then we got Ployz with her presentation, and then some, I guess, socializing afterwards. Right. Thank you.
Are you kidding me? So better? Ah, okay, like this. Hi, my name is Ploy. I'm a multimedia artist. Welcome to my presentation. Mine's gonna be a little bit more casual, nothing very technical, uh, like the other presentation. More like talking about my current obsession in this journey of try to explore. Basically, I'm trying to explore how to find a different method to drive the audio from touch designer with different kind of method, like a different way of streaming the data input basically to drive the audio. And I'm going to demonstrate my patch before I'm talking into detail of what's it all behind all of this. So I'm gonna play with my patch just to show you before I'm getting to detail a bit. think I demonstrate enough. And basically, this is drive by the apps called SixSim. But before we go into that, I'm just gonna wait. Let me turn off the sound in Bitwig. So to talk a little bit about my work today, I'd like to go back to my background a little bit. Basically, I I have been learning touch designer since 2019, but the point of learning touch designer, basically I start because of music, and well, I'm grow up into the MTV era, if you know the age. If anybody growing up in the MTV era, I'm the one, like watching MTV straight all along, 24 hours. So I'm very obsessed about music, but never really got to the point to make music for such a long time, and start touch designer basically because of the want to do VJ and explore to create the visual for audio reactive, and explore into the VJ workflow basically. But since recently, and you can see my old work that is like always using the audio data to drive visual. And it's been 5 years, and then now like I'm start to looking for something opposite, like, because I never really create audio, but more like offset with sound, but only make visual for sound. And now I'm doing like, what if I use the tool like Touch Designer to be the main architecture to drive, create all kinds of data to drive the sound, basically. And recently, I have been explore all kinds of method, that how do I using all kinds of data to trigger the audio. Like this was like 2 years ago. I used the Arduino Leonardo to as the capacitive touch MIDI controller to connect with this one is a stone. Not all the stone it work, but some is stone, some is like fruit and vegetable to trigger the sound. This one was like trigger from Ableton. I haven't learned Bitwig yet, but it was like use all kinds of the capacitive object to trigger the sound from Ableton basically, and then audio reactive on top of that. Basically, like it's like a loop of you create the touch, and the touch send to the object, and then the object create the sound, and then use the sound back to touch designer to create animate the visual. And that's kind of loop that I've been obsessed for quite some time. And maybe I can generate the sound with this. Oh, the sound doesn't come out. Okay, doesn't have the here, yeah. So like different sound is trigger different animation, and it's a night loop, and that would keep me like ongoing, because you have a proper circle of making a complete looping data. And that was like a very early stage. And recently I also like explore some more, like this one is basically I'm start to like try to get the simpler of the data stream, basically just use waveform like LFO, and explore what kind different kind of form, like Gaussian sine wave, how does the audio behave, and use the amplitude to manipulate how the sound behave with different kind of waveform basically. And that's like a very simple how you feed the data stream into to trigger the sound. And yeah, the exploration is keep further. And then another example would be basically using the tracking data to tracking the motion of each artwork. Basically, I'm using my own artwork to trigger the sound based on the tracking data to drive the audio. It's not so loud. And trigger different instrument, basically, like different kind of data, and then trigger different kind of instrument. And yeah, that's my, basically I'm explore all kinds of data input. What else can I use to trigger the sound? And another interesting that I've been also playing with, but it's quite a little bit tricky. I was using simulation. What's going on here? Okay, interesting. So this one I'm using basically dynamic simulation just to see how the sound behave. And basically in touch designer it would call NVIDIA Schaefer, and using a different dynamic to drive the audio. And basically I'm playing with the manipulate influence the sound by playing with the mass of the ball, or the friction, or the gravitational acceleration, the way it moves, and use the collision data just to trigger the sound, and also of course loop back to use that sound to audio react to create an animation. So this is kind of loop that I've been doing for quite some time, and see the behavior of the sound would behave. And this one is quite tricky because it's like at some point the ball would just like stop moving, and then it's getting out of the collision box basically that I create. So it's not that very practical, but it's also giving you basically giving me a sound that moving alive, like the way of the dynamic would work. But it gets very confusing, and well, dynamic is itself is very rigid, and it's quite hard to control. I'm just very early process of playing with this thing, but it's been fun. But as you can see, like I have so many ball, and the ball behave different, and each ball control have a different kind of value, like a different mass, different friction, and it gives a different certain behavior. So, and now, yeah, I can talking about the one that I just present, the one that, let me turn off the sound. Basically, for this one, so beside the waveform, beside the dynamic simulation, I'm just like, okay, what else that I can do? I'm using basically the 6sim. If you don't know 6sim, 6sim is I'm not sure it works with the Windows, but I doubt it's only work with iPhone. It work with Android. Okay, good. Basically, 6sim allow you to control your smartphone to get all kinds of data. For example, like gyroscope, gravitational data, and send those data to OSC protocol messaging. And you just control, you have like compass, basically acceleration, GPS. You can have touch cow, basically. That's what I just demonstrate before. And the one I used demonstrate before, basically I only used gravity, like XYZ position, just to mapping the sound. And yeah, for this one, I get the data from the 6sim, and then separate them into X, Y, Z of the gravity, and then each gravity connect to different instrument basically, and each and one instrument I also separate them into different node, and it get confused easily. That's why I have to like make sure like the connection basically is through the MIDI loop, basically a loop MIDI. It's an open source. You can download it for free. Basically, it gives you the connection to connect the audio software and Touch Designer. I haven't mentioned yet. I'm using the Bitwig in this case. I really like Bitwig. I mean, maybe most of you using Ableton. I've been there. I think it's too complicated for me, so I'm start using Bitwig, which is like as good as Ableton. And the wonderful thing about Bitwig is you have a Touch Designer have a built-in component where you can have like bi-directional communication. So if I want to control some effect in Bitwig, I have a ready-made like Touch Designer have a tool that allow you to control some effect in Touch Designer as well. Basically, this one. So yeah, this is my connection to Bitwig. So basically, you have connection here, and then you can pretty much control a lot of effect from here. But I haven't set up many effect here, but you can manipulate the Bitwig sound effect directly, and you can send back and forth. It's quite convenient, and I like the interface of Bitwig as well. That's easy for me to use. And yeah, you can see here that it's like you can have a different track, and you can control each track separately and the effect separately. So what I have been done here, basically, I have like I call my MIDI loop MIDI into color because it's easy to remember. So like, okay, I call it blue loop, and I call it green loop, and then I call it red loop. So all the color is my different instrument basically, and one instrument represent one color, and one color can have like a different note to trigger. And yeah, for the visual, basically I'm using instancing that it convert using the RGB data. No, I'm using 3 channel and then convert into RGB, and then RGB into the XYZ position to generate this kind of point cloud cube. Basically, you can see here. Where is it? Yeah. So from RGB to XYZ, and then I basically the audio generate the MIDI when it move, when I move left and right, up and down, is just gonna directly control the particle that you see here, basically. And yeah, that pretty much is. I'm wondering if anybody want to play with, just to play around with. Yeah, come. I forgot about it. The conclusion is basically when you have physical movement is influence a lot of the sound compared to the other streaming data. And that's why I feel like the more I explore, I'm trying to understand the sound and the way of data streaming, how much influence and giving a very unique texture. And that's what I'm been exciting recently, and just want to show more like my personal project that I'm still ongoing exploring. And yeah, so basically that's my obsession today. Let me know if you have any question. Any question? You mean the audio? How sensitive of the? I'm not sure I understand the question. Like, mm-hmm. Okay. Currently, it's just like okay. The question is like what kind of data that is coming to my patch, right? Basically, currently it's just the gravitational data, XYZ, and on top of that, it's just touching. But I think nobody really touching, basically. Touching and then generate another sound. So like 3, 4 incoming data. I think the more is too complicated, and I'm already confusing by the data to drive a different instrument. Basically, I separate one X to one instrument, another Y, another instrument, and C, another instrument, and just to trigger the rotation and tilt it, and then get another sound and tilt it the other direction to trigger another sound, basically. And yeah. Any question? Yeah. Thank you. Mm-hmm. Mm-hmm. The difference between the TD Ableton and Bitwig, right? It's personal. More like personal reason. I also start with Ableton as a workflow like for the sound input, but then I'm not a sound person, and then I find Ableton very headache just to play around with, and I've been trying almost a year in Ableton. I actually gave up, to be honest, and then I found Bitwig, and I was like, oh, it's such a cool interface, and then I know that they are the same group of people that they did the Ableton, and then they do Bitwig later, and the interface of Bitwig is a lot more simpler for a non-audio person like me. And the another cool thing about it's like, yeah, touches, and I have a built-in component where basically pretty much similar to TD Ableton, but also like by directional communication that I can also control like the effect, which is like a lot more intuitive in my own workflow understanding of the sound, and it worked equally. If you're good with Ableton, I would go on with Ableton. But for me, as a non understanding about much the sound or the AW, the DAW system, the interface, for me Bitwig is the best. And I like the effect of the Bitwig as well, the sound, how it behaves. And also like Bitwig have like a controller is the setting of the controller easy to connect. It's like pretty fast of communication, basically, of Tachitana and Bitwig. It was like quite impressive for me, and then I stick to that. It's like, okay, I'm not changing anymore, basically. Mm-hmm. Mm-hmm. Which one first, of the inspiration or workflow, right? The aesthetic. I'm actually, I always make something beautiful first, and then I'm doing something later. That's how my usual workflow. Because I'm before I discovered touch designer, I'm basically a motion designer. I'm do anything visually workflow. So uh, anything else like the workflow of node base is like secondary. I'm trying to achieve anything that look good, and then I'm playing with the system later, and that's usually my workflow. But this one is like, I don't know if you are if you are the designer. Most of the designer that I talk with, they are like, if it doesn't look good, you kind of cannot move further. You want to make it look good. I said, oh, you feel good now, and then you can do something else. And that's usually how I did it for 10 years of being a visual designer and motion designer. And it's, when it look good, okay, now I can play with something else that it need to be fixed. It need to be done basically. And yeah, that's the how my usual workflow is. Any question or thumbs up? Yeah. Okay. Thank you.
All right, thank you. Wow, it's very loud. Yeah, we're done with our program. Thank you so much for joining. You can hang around for a bit, socialize, and also check out Anna's installation in this room. And yeah, yeah, play around. Yeah, you can interact with. There's a remote control that you can change between different like visuals. And yeah, I don't know, hanging around for another hour or so. Yeah. And again, see you hopefully again on May 29th. Check out our workshops on our website and yeah.
If you're into a MIDI generating sound, like William already said, like we have like a MIDI controller, wireless MIDI on this weekend on Saturday, but it's sold out. But we also have Sunday that is still available. I'm gonna be here on Sunday to attend as well. It's my favorite topic. So if you're into, join me on Sunday. It would be really cool and having fun. Yeah.
Sweet. Thank you so much for being here.